All right, welcome back. We are at chapter 21 now, Tic-tac-toe, and it's a rather simple game, and that's the point. You already hopefully really understand the idea of the game, and so we're going to dig into how we would represent this with a computer program. And one of the things that we're going to be exploring is this idea of state. We're going to take it in two steps. First, we're going to write a version of the game that just plays one turn. So given a state of the board in some condition, maybe it's completely blank and open, and we just want to put an X on the board, we want to change the state and then show the board. It could be, though, that maybe there's already a player has occupied one of the cells that we're trying to change, and so we're going to have to detect that. And then we're going to have to, in the end, determine if somebody has won the game after this one round. And then we're going to be able to take that in chapter 22 and turn it into a fully interactive version that will play all the way to the end. So there's a little bit of background here, just talking about usually the inevitability that tic-tac-toe ends in a draw. So talk a little bit about War Games, one of my favorite movies. And so we're going to be digging in to the idea of state. One of the things I bring up here is that we saw this in the previous chapter when we were using the random module, how this idea of state is global to the program. And so when we did things kind of out of order, it made things work differently under one condition than it did under another. And so we're going to try to bring the idea of state really front and center. There are two things that we really have to think about in this version of the game. One is, what is the board at any one particular state? There are 9 squares, and so we have to think about a way to represent those 9 pieces of the grid. And then once we've possibly altered the grid, we're going to have to determine if there's a winner. And so some of the things that we're going to have to figure out is, like, how do we represent those 9 pieces of the board? Are we going to use a list? Are we going to use a string? Do we want to use a dictionary? You could use any of those. How are we going to enforce the rules? How are we going to prevent a player from taking a cell that's already occupied? How will we verify that a given board is actually valid? Like, for instance, we're only going to represent X's and O's in open cells. How do we represent that? How do we make sure that the board state that's being given to us is actually valid? We're going to use and or to reduce the combinations of Boolean values. So that's something that we've looked at before, and we're going to continue with that. When we define what it means for the board to have a winner, how do we write that? So there's more than one way, more than one winning configuration. All X's across the top, all O's across the top, or up and down, or diagonally. So how do we represent those? I'm going to show you how I use a list of lists to define the winning positions. I'm going to use the enumerate function, which is something I use quite a bit and find really, really useful. And so those are some of the things we're going to be studying in this chapter. We will continue in the next video.